Today's lecture's topic is if function. And with if function, one example of things we might end up doing is the calculation of the income tax. For instance, with even the simplest form of what's called, we'll see it in a second, but what's called a proportional income tax. We have two options: whether the person is under the taxable income, in case of which he will pay $0 as his income tax, or he's over it, in which case he will be paying some tax. So that's what we'll end up doing. But in order to get there, we should start with something called conditions, which are used in an if. An example of a condition would be, let's consider the temperature we have outside. We have a number of cells now that are written out here. The first cell is named cold, which basically means that in a northern country, in the month of June, if the temperature is 15 or below, we consider the temperature to be cold. The other temperature is hot, which once again here in a northern country could be in June 25 degrees of centigrade, and you'd consider the temperature to be hot. And let's say that right now the temperature is 22 degrees centigrade. Now the first condition we could construct would be we could compare cold and hot, since we write the equal sign again in the beginning of this comparison. This equal sign will tell Microsoft Excel to calculate things. But now our remaining portion of the formula is cold equals hot, and there we're comparing whether 15 and 25 are equal. So the second equals sign actually does comparing, and since they don't equal, Microsoft Excel will return false. Well, this will not work. The second example of a comparison would be, let's check whether cold perhaps is bigger of a temperature than hot. We write equals cold bigger hot, and since 15 is not bigger than 25, this again will be a false. And to bring the last case would be to, let's say, make such a comparison in which we check whether cold is smaller than or equals to hot. Well, first of all, it is, so the formula will return this time will return true, or that's the truth here. But what we also see is that this time we've written smaller than or equals to. Well, cold is strictly smaller than hot, so this would have been true already. But sometimes we need that smaller than or equals to. For instance, in case of income tax, if your income is smaller than the taxable amount, the non-taxable amount, or equals to it, you'll still be paying no income tax. The other point to make here is that if we write smaller than or equals to, we should always write the smaller than character before, so not after the equal sign. So that's how it looks like. The next topic would be to make some kind of a more complex comparison. For instance, here we are comparing whether now 22 is between cold and hot, 15 and 25, which it is. The formula is written down just directly like that, but it turns out that it doesn't work. If we consider, if we try to write it out as, in smaller bits, let's say we check whether cold is smaller than now, and it is. 15 is smaller than 22. We get an OK. Now The next thing we might try to do is we check the last answer, which is true. We check whether the last portion is like smaller than hot. And probably this is something. This is what Microsoft Excel does. It gets a true from the first formula, and then it tries to compare this true to something called hot, which is 25 degrees of centigrade. So it actually returns something. It returns false, but this is erroneous. This is an erroneous result wherein we actually don't find out that there has been an error made. So we have to know that whenever we have such a more complex comparison, we have to write it down in some kind of another way. And now the way to do it is as follows. We have to break the more complex comparison or condition down into parts. The first part being cold is smaller than or equals now. The second part being now is smaller than or equals hot. We break it down into simple parts, so Microsoft Excel really only feeds on atomic or the smallest possible comparisons can be only done. And then we write those smallest possible comparisons inside what is called an AND. And when we start looking at this AND, it turns out AND is a function. It's a function as every other. It begins with parentheses, and it's a function that only gives us truths and falses. So this is the special nature of it. And when we do a comparison, cold is smaller than or equals to now, then we write a semicolon. This separates the two things and consists of. And now the second part is now is smaller than or equals to hot. We break the more complex comparison into smaller parts. We write these parts inside an AND, and an AND will work just correctly. There's one more point to be made. AND will give us true, which is the correct case, and which is the case right now. Will give us true only if the first comparison and the second comparison both work. So, for instance, if first doesn't hold and the second holds, it will give us false. If the first holds and the second doesn't, it will give us false. If neither holds, it will give us false. So AND only works if the first thing and the other both work. That's how it does its operation. Plus we got our problem solved. And before we go into writing those formulas ourselves, let's take a little look at how things are compared if text is concerned. Namely, it turns out that all the letters in our alphabet, all the words that we save with a computer, are actually saved as numbers. And there is a function, special function called code. For instance, if we write equals code F12, and F12 contains A, then it gives us the code of letter A. Letter B is 66, letter C, A is 65, letter C is 67, and so they go. And now it turns out that if we compare, this is less applied in the present situation, but it's important for something that's going to come later on. If we compare, for instance, two names of women, one is Malle and the other is Mai. If we compare them, then what Microsoft Excel does, it takes those letters one by one, and we could say that it makes a dictionary comparison. What we mean by that, we write, for instance, let's see which word comes before in a dictionary. M's are the same, A's are the same, I comes before L, my, Malle. I comes before L. So if we write equals, my is smaller than Malle, it's going to be true. If we had written it the other way around, Malle is bigger than my, it's going to be, if we had written it Male is smaller than my, then it has been false. And it basically, just to show you that it does it full dictionary comparison, even if the word my is very long, my, then it still comes before in a dictionary, and the word is, so to say, smaller. We're gonna need it in the future, but let's leave it at that at the moment.